Precision is the secret sauce in making anything, from spaceships to birdhouses. Whether you're building a towering skyscraper or crafting a simple wooden box, the need for accuracy is universal. Every project, big or small, relies on the ability to measure and control dimensions. Without precision, even the most creative ideas can fall apart. It's what separates a masterpiece from a mess and a reliable product from a risky one. It's the difference between a perfect fit, where every part slides together smoothly, every joint is tight, and every edge lines up just right, and a pile of scrap, wasted time, and frustration. When measurements are off, even by a tiny amount, parts don't fit, assemblies fail, and materials are wasted. Mistakes multiply, and what should have been a finished product ends up in the bin. So, how do we achieve this level of precision? We measure. Measurement is the foundation of all engineering, manufacturing, and craftsmanship. It's the process that lets us control the outcome, repeat our successes, and improve our designs. Measurement is the language we use to command materials to fit our vision. It's how we communicate our ideas to the physical world, translating sketches and blueprints into real, tangible objects. Every mark, every line, every cut is guided by numbers and units that ensure everything comes together as planned. Every object made by human hands started with a measurement. From the earliest civilizations using simple sticks and ropes to today's digital calipers and laser measuring devices, the act of measuring has always been at the heart of creation. It's a tradition that connects us to generations of makers before us, and it's a skill that continues to evolve with technology. Without measuring instruments, we'd be guessing, not engineering. Imagine trying to build a table or repair a machine by eye alone. Nothing would fit and nothing would last. Guesswork leads to errors, inconsistencies, and disappointment. Measurement brings order to chaos, turning random attempts into reliable results. Measurement turns ideas into reality, bridging blueprints and physical objects. It's the critical step that transforms a concept on paper into something you can hold, use, or even live in. Every successful project is built on a foundation of careful, accurate measurement. A tiny error can halt a project, causing delays, extra costs, and endless headaches. Even a fraction of a millimeter can mean the difference between success and failure, especially in fields where tolerances are tight and safety is critical. In industries like aerospace, automotive, and construction, a single measurement mistake can lead to catastrophic failures, putting lives and investments at risk. That's why professionals rely on precise tools and strict standards to get it right every time. But measurement isn't just for experts. Whether you're a hobbyist, a student, or someone just starting out, understanding how to measure accurately is the first step toward building something real and lasting. It's a skill that empowers you to create, repair, and innovate with confidence. In this guide, we'll explore the world of measuring tools, rulers, calipers, micrometers, and more. We'll see how they work, what makes them accurate, and why choosing the right tool matters for every job. This isn't just theory, it's practical knowledge you can use right away. You'll learn techniques for getting reliable results, tips for avoiding common mistakes, and ways to build your measuring skills over time. It's about understanding your tools and using them to bring your creations to life. With the right approach to measurement, you can turn your ideas into reality, one precise step at a time. Let's dive in and unlock the power of measuring. Let's take a step back and ask, what is a measuring instrument really? It's something we use every day, often without even thinking about it. But what does it actually do? And why is it so important in our lives and in the world of engineering? At its core, a measuring instrument is a tool designed to determine the value of a physical quantity. Whether it's the length of a table, the volume of a liquid, or the temperature of a room, these tools help us quantify the world around us. The basic principle is simple. It compares an unknown quantity to a known standard. Think of a ruler's markings. Each line represents a fixed length, and by aligning an object with those lines, we can find out exactly how long it is. In engineering, measurement is everywhere. We measure length, angles, temperature, pressure, speed, and so much more. Each of these quantities is essential for designing, building, and maintaining everything from bridges to smartphones. And for each type of measurement, there's a specific instrument, each one a clever solution to a unique problem. From the simple ruler to the complex micrometer, these tools are the backbone of precision. But how do we make sure these measurements are accurate and reliable, no matter where we are in the world? That's where metrology comes in, the science of measurement. Metrology ensures that our measurements are not just close, but precise and consistent, whether you're in Tokyo or Toronto. This shared language of measurement is what allows engineers and manufacturers from different countries to work together seamlessly. It's the foundation of global collaboration and innovation. So, while measuring instruments might seem ordinary, they're actually the unsung heroes of the modern world. They ensure that every part fits perfectly, every product works as intended, and that progress keeps moving forward, one precise measurement at a time. Let's delve into the fascinating world of measuring instruments and how they display results. Today, we compare analog and digital readouts, two distinct methods that have their own unique advantages and challenges. Analog instruments, such as dial indicators and micrometers, use a needle on a dial. This method offers a physical, intuitive feel that many find satisfying. The movement of the needle provides a visual representation of the measurement, which can be particularly useful in understanding trends and changes over time. However, while they show context and rate of change, analog tools can be tricky to read precisely. Parallax error, where the angle of viewing affects the reading, can lead to inaccuracies. This requires careful alignment of the eye with the needle to ensure precision. On the other hand, digital instruments provide a clear numerical readout, which significantly reduces human error. The digital display eliminates the guesswork, offering precise measurements at a glance, which is especially beneficial in high-precision tasks. Digital tools also offer the convenience of switching between metric and imperial units with just a press of a button, making them versatile for various applications. However, they lack the tactile feedback and intuitive feel that analog instruments provide. A notable downside of digital tools is their reliance on power. A low battery can halt operations, whereas analog tools offer old-school reliability, functioning without any power source, making them ideal for environments where electricity is scarce. Ultimately, the choice between analog and digital depends on the specific task at hand and personal preference. Some may prefer the precision and ease of digital, while others might favor the reliability and tactile feedback of analog. Each has its place in the world of measurement. Let's look at how these tools work, starting with mechanical instruments. They use gears and levers to magnify movement into a readable measurement. Mechanical tools are robust and reliable, but limited by physical components. Electrical instruments convert physical quantities into electrical signals. Strain gauges measure changes in resistance to calculate strain. Electrical tools opened new measurement possibilities often used for remote sensing. They require power and calibration to ensure accuracy. Electronic instruments use active components for signal processing. Digital calipers use microprocessors to display measurements on screens. Electronics offer precision and features like unit conversion and data transfer. Optical instruments use light for measurements, from magnifying glasses to lasers. Laser scanners create 3D models with incredible accuracy. Optical methods are non-contact, ideal for delicate or hard-to-reach parts. They represent the peak of measurement capabilities. Organize tools by what they measure: linear, angular, or surface qualities. Linear tools range from steel rules to micrometers for high accuracy. Angular tools include protractors and sine bars for precise angle measurement. Surface finish tools measure microscopic peaks and valleys. Instruments exist for pressure, temperature, speed, and hardness. For every engineering question, there's a specialized tool to answer it. Do tools need to touch the object? This divides them into contact and non-contact. Contact tools, like calipers, provide direct, reliable measurements. Non-contact tools use light or sound, ideal for delicate or inaccessible parts. They offer speed and accuracy, but can be costly and complex. The choice depends on the part, material, and production needs. Measuring tools are vital in industries like automotive and aerospace. In automotive, precision ensures engine parts fit perfectly. Aerospace uses non-contact tools for safety-critical components. On manufacturing floors, a range of tools ensures quality and consistency. Even in medical devices, precision is key for implants and joints. Measurement is the foundation of modern innovation. We've explored the world of measuring instruments, the foundation of engineering. Start with basics like a steel rule and digital caliper. Measure everything, learn their limits, and make mistakes. These tools become partners in creation, extending your hands and mind. Mastering them is a rewarding journey, essential for every project. Be curious, be precise, and go make something amazing. The world is waiting, and your tools are ready to help you build it.